In this video, we're going to talk about the different levels of measurement. Understanding levels of measurement is really important to understand what type of data analysis you can do with your data. So the different levels of measurement are consecutive. We start with nominal, then we consider whether or not it's ordinal, then interval, then ratio. So nominal is the most simple type of data, and ratio is the most rich, informative type of data. Okay, so starting with nominal, this is data that consists of names, labels, categories, though order is meaningless. Okay, so for example, if you were to ask someone what their party affiliation is, they would tell you Democrat, Republican, independent, and there's no order to those categories. Someone who is Democrat, it doesn't mean they're worse or better than someone who is a Republican. There's no ordering. This is just nominal type of data. Second, we have ordinal. Okay, so ordinal type data has order to it, but the difference between data values is meaningless. So this type of data, so consider someone were to ask you to fill out a pain scale and tell you how much pain they're in. Then you could say, okay, so 0 is the least amount of pain and 5 is the most, and someone who is in pain, who answers and says that they're in pain 4, is definitely in more pain than someone who answers and says that they're in pain 2. But if you were to take the difference between 4 and 2, it's a pretty meaningless difference. Okay, so that would be ordinal type of data. Next, we have interval type of data. So in interval type of data, you can actually take the difference between two data values, and that's meaningful, but there's no natural zero. Okay, so an example would be years. Okay, so years, and if something, you're asking when specific events happened, you're asking data that consists of years, and say something happened in the year 2000 and another thing happened in the year 1000, you could take the difference and you'd say, okay, well, this was 1,000 years later, right? There's no natural zero, right? The year 0 that is not an absent of time, right? That's not an absent of years. So because the year 0 it does not mean that there's an absent of years, you can't do things like take the ratio. You can't take 2,000 and divide it by 1,000 and say, well, 2,000 is twice as many years as 1,000. No, that doesn't really make sense. The next level of measurement, you can do that, and that's why it's called ratio. All right. So, for example, if you were to think about someone's weight, say one person is 160 pounds and another person is 80 pounds. That's twice as heavy, right? And the reason why taking that ratio makes sense is because being a 0 pounds is a meaningful 0. We know what 0 pounds means. It means it doesn't exist, right? It has no weight, right? So, something can have no weight, and so that's why weight is a ratio. It's a ratio level of measurement. Okay, so now let's move on to a few examples where we have to identify the level of measurement for the following variables, starting with hair color. Hair color. Now, when we're considering the level of measurement, we'll consider first nominal, then we'll build up and see if it's ratio. Now, is hair color nominal? Well, it's different categories of hair color: blonde, brunette, redhead, what have you. But there's no order to hair color, right? Having one color of hair doesn't make you better or worse than someone with a different type of hair color. So because we stop there at ordinal, we know it's not ordinal, so it must be nominal. Hair color is nominal level of data. Okay, next, moving to zip code. Zip code puts you into a category for where you live, right? So that's your category. Is there an order to zip code? No, right? One zip code is not better necessarily than the other. So not ordinal. So we stop here. Zip code is a nominal type of data. Next, moving on to your letter grade. So this would be A, B, C, D, F. That puts you into a category of what type of grade you got. All right. Is there an order to your letter grade? Yes, right. An A is better than a B. Okay. Can you take a difference between letter grades, and is that difference meaningful? Well, no, right. You can't really take the difference between an A and a B, right? Differences are usually left to numbers. So taking a difference between two letters doesn't really make much sense. If we had, instead of letter grade, but maybe your percentage, your grade percentage, well, that would be different. But just the letter, you can't really take a meaningful difference between letters. So ordinal it is. All right. Now SAT score. Now SAT score puts you into a category of what score you got. And then there's an order to your score, sure. If you got 1600, that's better than someone who got 1100. Can you take the difference between SAT scores? Yeah, if someone got 1600 and another person got 1100, those 500 points are meaningful, right? I mean, universities will make decisions about whether or not they'll accept someone based off of that difference, right? So, the difference between the SAT scores is definitely meaningful. Is there a meaningful zero, right? Can you take the ratio between SAT scores? No, not really, right? Because SAT scores, if you remember how it was scored, there's no zero SAT score, right? And a lot of standardized tests work this way. IQ scores usually work the same as well, right? If you get a 0 on IQ score, it doesn't mean you have zero intelligence, right? SAT score is the same thing. It doesn't start at 0. Getting the lowest score possible, or getting nothing right, does not give you a 0 SAT score. So there's no natural 0 in most standardized tests. So this is not ratio. Instead, it is interval. Okay. Now your height. Height. Okay, that puts you into a group of how tall you are. It has order to it, right? If you're 6 feet, that's taller than someone who's 5 feet. Or 3, for example. Interval, can you take the difference, right? If someone's 6 feet, they are 1 foot taller than someone who is 5 feet, and that interval makes sense. We know what that interval means. We know what a foot looks like. So yeah, the interval, the difference makes sense. Is there a natural 0 for height? Yeah, right. If someone, you can take ratios between heights, right? Having 0 height is meaningful. There's a lack of height, right? And someone who is 5 or 10 feet or something that is 10 feet is twice as tall as something that's 5 feet. And so, yeah, taking ratios makes sense for height. So, yeah, height is a ratio type of data. Age, right? Age is a category for what age you are. It has an order to it. If you're 26, you're older than someone who is 13. There's, if you take the difference between someone who's 26 and someone who's 13, each year is a meaningful difference. The difference is meaningful. And if you have 0 years of age, that's meaningful. It means that you have lack of age, right? So if someone who's 26 compared to someone who's 13, they are twice as old. So, right. So age is ratio, a ratio type of data. Next, temperature. And now temperature. Temperature is... it's a category for what temperature it is. Let's talk about temperature in degrees Fahrenheit for the purpose of this conversation here. So temperature in degrees Fahrenheit. So say 80 degrees versus 40 or something like that. That puts you into category of how hot it is, right? There's an order. 80 degrees is definitely hotter than 40 degrees. You can take the difference between 80 and 40. Yeah, it means 40 degrees hotter, right? Can you take the ratio between 80 and 40? Actually, 80 degrees is not twice as hot as 40 degrees. No, it's not. The reason is because 0 degrees does not mean that there's a lack of temperature, right? 0 degrees Fahrenheit is just a marker between negative degrees Fahrenheit and positive degrees Fahrenheit. It doesn't mean that there's a lack of temperature. There's no natural 0 to temperature. So temperature is not ratio, it is interval. Okay, lastly, you are in a statistics course and you're about to be taking quiz 1. I'm going to get the data for all of your scores. Is that data? What level of measurement is that data? Okay, your score will have a category, right? That's going to be what score you got. There's an order. If you get a perfect score, 100%, compared to someone who got 20%, that is meaningful. There's a meaningful order to the data. You can take that difference. That difference is meaningful. For each problem that you get right, you will have a meaningful increase in your score. And if you get a 0, that is meaningful. It means that you will get nothing right on the quiz. So there is a meaningful 0, and someone who gets 100% did twice as good as someone who got a 50%. So your score on the quiz is a ratio level of data.